We're going to spend the last part of this lesson discussing exterior angles and working with exterior angles. Identify each exterior angle and calculate the sum of the exterior angles for each polygon. We have a triangle, and for you, I've already drawn the exterior angle. Remember, we just extend one of the sides and we have an exterior angle. Remember also that the interior and the exterior angle create a linear pair, therefore adding up to 180 degrees altogether. If that's the case, if this is 50 degrees interior angle, the exterior angle will be 130 degrees, 180 minus 50. Similarly, we have a linear pair right here, therefore the exterior angle from this interior angle measures 120 degrees. And similarly for this last interior angle, the exterior angle will measure 110 degrees. Let's now do what the directions say, adding up, finding the sum of the exterior angles. The first one I did was 130, the second one was 120, the third one is 110. What do we get when we add all those together? 360. The sum is 360 degrees. Let's now take a look at the quadrilateral. Here's an exterior angle from the right angle, therefore 90 degrees, since 90 plus 90 is 180. Here's another exterior angle. This one measures 89 degrees because we want those to add up to 180 degrees as well. 92 from 180 gives us 88 degrees for this exterior angle, and 180 minus 87 gives us 93 degrees for this exterior angle. Remember, all that we are doing is recognizing that the interior and the exterior is a linear pair adding up to 180 degrees. Let's now find the sum by taking all of these exterior angles. 89, 88, 93, and 90. Add all of those up and you get 360 degrees. Again, the sum is 360 degrees. Notice that we had 3 angles here and 4 angles here, and yet the sum is still 360 degrees. No matter what kind of polygon you have, the exterior angles will always measure 360 degrees. In fact, that is the polygon exterior angle theorem. The sum of the interior angles has a special formula, but the sum of the exterior angles is always 360 degrees. The sum of the measures of the exterior angles of any convex polygon is 360 degrees. No fancy formula for this one, but still something that you will need to memorize. Perhaps you take a look at this link that I've opened and you can play with some things about polygons a little bit. I'll show that to you in a moment. I want you to see a little bit more of why the angles that are exterior will add up to 360 degrees. In this picture of a 1, 2, 3, 4, 5 pentagon, I'm going to take out the exterior angles, angle 1, angle 2, and I'm going to put them vertex to vertex so that they are all adjacent to each other. And I want you to notice that when we do that, and then we add up all of those angles. So take a look at this. Angle 1 put together with angle 2, with angle 3, with angle 4, with angle 5. What does it make? A circle. How many degrees do the angles of a circle make? And when I say the angles of a circle, I mean the angles put together that create a circle. All the way around a circle makes 360 degrees. Let's take another polygon. This time I have 1, 2, 3, 4, 5, 6. I have a hexagon, more angles. But if I take each of these angles and put them adjacent to each other, what's going to happen here? Does it make anything different than the circle it made the first time? Nope. Angle 1, angle 2, angle 3, 4, 5, 6, all the way around to make a complete 360 degrees of circle. Let's apply our exterior angle theorem. Use the Polygon exterior angle theorem to solve for x. Exterior angles. As soon as I see that, I just think to myself, 360 degrees. That's the sum. They all add up to 360 degrees. Not much thinking here. Let's add them up to solve for x. So similar to what we did before, let's just keep track and not miss any. So as I go, I'm going to place a mark by them. 3x plus 2, 3x minus 5, 2x plus 3, 4x plus 10, x minus 10, and 2x plus 60. Add them, and they're supposed to equal 360 degrees. Now, what if the directions didn't say use the Polygon exterior angle theorem? I still know that I'm supposed to add them to make 360 because these are exterior angles. They're outside of the polygon, outside. Let's combine our like terms. 3 and 3 is 6, 7, 8, 12, 13, 14, 15. We have 15 x's. Adding up all our constants, we get 60. There we have a nice simple equation, and we can get x by itself. So from 15x equals 300, dividing gives us that x equals 20. Not too bad, right? Finally, find the measures of an interior angle and an exterior angle of the indicated regular polygon. Notice the words that I emphasized. An means one. I just want one interior and one exterior. Remember earlier how we found one interior angle? We had to use the interior angle theorem, n minus 2 times 180. But remember what we just learned about the exterior angles. They all add up to 360. Which one would you rather do first? The one that has less stuff, the easier one, or the one that has more stuff? Doesn't really matter where we start, we're going to have to find both. But there's definitely an easier route if we pick the simpler one. Let's take a look at it. All of them add up to 360, all of the angles. Well, all of the angles are congruent because this is regular. There are 6 of them because hexagon means we have 6 of them. So I'm going to take the sum and split it up evenly between the 6 congruent angles. 360 is the sum, divide it by 6. That means each exterior angle is 60 degrees. So one exterior angle measures 60 degrees. Now we want an interior angle measure. So I could use my formula, or remember what an exterior angle looks like. If I draw just any polygon, I'm going to draw a hexagon, but it doesn't really matter. And then I'm going to draw an exterior angle by extending one of the sides. This angle that we just found right here is 60 degrees, exterior. Where's the interior angle? That's right next to it. Now they're not the same. Notice this one looks a lot bigger than this one that's 60 degrees. This one is obtuse. But what do we remember about the two angles next to each other on a line, the linear pair? Are you thinking to yourself, yeah, we said they're supplementary. So I know that to get to the interior angle, 180 minus that exterior angle, 120. And doesn't that make sense for this big obtuse angle? So I can say the one interior angle measures 120 degrees. Done.